Lesson 10-4, Factoring Differences of Squares. And in this lesson, you learn to identify and factor binomials that are differences of squares. Okay. And before we go into the lesson proper, let's take a look at how to factor using difference of squares uh, by using algebra tiles. Okay. So you have used algebra tiles to factor trinomials. You can also use algebra tiles to factor some binomials. So we want to factor x squared minus 9. And first things first, we need to model x squared minus 9, which is this one. You have x squared minus 9. We'll have one x squared tile and 9 negative unit tiles, negative 1 unit tiles. Okay. Step number 2. Place that x2 tile at the corner of the product mat. Arrange the 1 tiles into a 3 by 3 square, so just like what's shown. Okay, now if you notice, this is not a rectangle. When we used to factor trinomials, we have to form a rectangle. This does not form a rectangle, so what we need to do is this. Step number 3, complete the rectangle by using 3 zero pairs. So 3 zero pairs would be 3 negative x tiles and 3 positive x tiles. Okay, and that'll create your zero pair. And then find the length and the width. So if you notice, this one is x minus 3. Okay, because this is an x right here. This is an x. And this is 1, 1, 1, sorry, negative 1, negative 1, negative 1. That's why it's x minus 3. And this is an x right here. And this is 1, 1, 1, which makes it x plus 3. Okay, and we have factored our x squared minus 9 as quantity x minus 3 times quantity x plus 3. Now let me take this one step further. And actually, we can factor x squared minus 9 using power of x. So in x squared minus 9, I can rewrite this as x squared minus 0x plus 9. So if I use the power of x, that would be 9, and this would be 0. What would be the factors of 9, which will give me a 0? That's negative 3 and 3, and still end up with x minus 3 and x plus 3. So using the method x, or the power of x, we have x minus 3 as and x plus 3 as the factors of x squared minus 9. Okay, but let's use a pattern here, so which is a lot simpler than the power of x, or the x method. Recall that the product of a sum and difference of two binomials, such as n plus 8 and n minus 8, is called difference of squares. Remember, we did this in chapter 9, special products, last section, and I told you to not to forget this. So if you have n plus 8 times n minus 8, okay, and the difference of squares we just talked about, okay, you end up with n squared minus 64 using the FOIL method. Okay, so the modeling mathematics activity suggests the following rule for factoring the difference of squares. It simply tells us that, okay, if you have a squared minus b squared, it is the same as quantity a minus b times quantity a plus b, or it can be quantity a plus b times quantity a minus b. Okay, just like we did in special products. So all we need to do now, after knowing this pattern of difference of squares, we can simply find our a, simply find our b, and factor it a lot faster. So you can use this rule to factor binomials that can be written in the form of a squared minus b squared. Let's take a look at this one. M squared minus 81 is also the same as m squared minus 9 squared. And if you notice now, this is our a and this is our b. So if you use that factoring method, we now have m minus 9 and m plus 9. Okay. Remember again that a squared minus b squared is the same as, okay, a minus b times a plus b. In this case, our a is m and our b is 9. And that's how you get that factoring, the factored form of m squared minus 89. Okay, 100s squared minus 25t squared. Okay, again, we talked about in factoring this types of polynomials. First, we need to look for the GCF, or the greatest common factor. So the greatest common factor in 100s squared minus 25t squared is 25. So this becomes 25 times 4s minus t squared, okay, using the first method of factoring, GCF. And after that, now we have a difference of squares. This now becomes 25 times 2s squared minus t squared, okay, and this is our a, 2s, and our b is t. So this becomes 25 times 2s minus t times 2s plus t. Okay, let's take a look at example C. 19x squared minus 4 over 25y squared. Okay, now this is the same as 1/3 x squared and 2/5 y squared. Okay, we simply renamed 1 over 9x squared to become quantity 1/3 x, close quantity squared. Okay, and the same thing with 4 over 25y squared. We renamed it as 2 over 5y squared. Okay, and this now becomes our a, this becomes our b. So now we have 1/3 x minus 2/5 y times 1/3 x plus 2/5 y. And we can also, you always check this using the FOIL method. Okay? Let's take a look at example number 2. Sometimes the terms of a binomial have common factors. If so, the GCF should always be factored out first. Again, we've been doing this for the past examples. We need to find the GCF first and foremost. Okay? So after finding the GCF, then we can use the other factoring methods. Occasionally, the difference of squares needs to be applied more than once, okay, or along with grouping in order to completely factor a polynomial. Now, in these examples, we are going to combine all our factoring methods to be able to factor our polynomial completely. So let's take a look at the first one, 20cd squared minus 125c squared, c to the 5th squared. So first we find the GCF, which is 5c. And if we factor out 5c, we're left with 4d squared and 25c to the 4th. And from there, if you notice, there is a difference of squares here. So this is 5c times 2d minus 5c squared, 2d plus 5c squared, y. Okay, because from here, okay, this actually is 5c, okay, times 2d squared minus 5c squared squared. Okay, now you have a difference of square. That's a square, that's a square. This is our a, and this is our b. And that's why you have 5c times 2d minus 5c squared, 2d plus 5c squared. Okay? Let's take a look at the next example. You have 3k to the 4th minus 48. Again, follow what we talked about. Find the GCF first, and the GCF is 3. Factor out 3, end up with k to the 4th minus 16. Okay, so using the GCF method of factoring, so you have now k squared minus 16. And then, if you notice, this is the same as also k squared minus 16 is the same as k squared squared minus 4 squared. Okay, so from there we factor it to become 3 times k squared minus 4, 3 times k squared plus 4. Okay, but it doesn't stop there because we still have a difference of squares. K squared minus 4 is a difference of squares, right? Because this is k squared minus 2 squared. So that's still a difference of squares. So we still factor it. So now we have 3 times k minus 2 times k plus 2 times the quantity k squared plus 4. Now, big misconception, there is no such thing as a sum of squares. So k squared plus 4 cannot be factored, so that's it. Okay? K squared plus 4 cannot be factored as what you see here, so do not confuse yourself that k squared plus 4 can be factored, so leave it as is. And that's it. That's a fully factored form of 3k to the fourth minus 48. Let's take a look at the next example. 9x to the fifth plus 11x cubed y squared minus 100xy to the fourth. Again, to factor the trinomial, we need two numbers whose product is negative 900 and whose sum is 11. So we're using the power of x, or the x method. Okay, so if we use the x method, okay, even before we use the x method, okay, if you notice, there's a common factor x right there. So using the GCF, we factor out x first. Okay, and after factoring out x, then we do the x method. So the x method calls for, okay, 900, so the product of 9 times 100, and which has a sum of 11. So we are using now the power of x to be able to do this, okay, and we find out that to be able to get a sum of 11 from the factors of 900, we need to use negative 25 and 36. Okay, so using that, we can now rename 11x cubed y squared as x times 9x to the fourth minus 25x squared y plus 36x squared y squared minus 100 y to the fourth. And since the coefficient is not equal to 1, we group them as what you see here. And then find the GCF of 9x to the fourth minus 25x to the squared, and find the GCF of 36x squared y minus 100 y to the fourth, and we factor them out. So the GCF would be x squared, factor out x squared. We're left with 9x squared minus 25y squared because we factored out x squared. We factor out 4y squared in this case. You're left with 9x squared minus 25y squared. And using the distributive property, we add x squared plus y squared, and this becomes our C, 9x x squared minus 25y squared. So we now have x times x squared plus 4y squared times 9x squared minus 25y squared. And we now have, okay, a difference of squares in 9x squared minus 25y squared. And we continue factoring. Now we have x times the quantity x squared plus 4y squared. Okay, and then the difference of squares would be 3x minus 5y and 3x plus 5y. And that's how you completely factor this particular polynomial. Okay? Let's take a look at example number 4, or number 3. Okay? But before we get example number 3, example number 3 would be at the bottom. Let me just check. Yep, it is. So the difference of squares can be used to multiply numbers mentally. Okay, and let's take a look at this one. Show a method. Okay, there you go. Show a method for adding the product of 37 and 43 mentally. Okay, so this is pretty simple. This is the distributive property. So when since 37 is equal to 40 minus 3 and 43 is 40 plus 3, we can actually use the difference of squares to solve this mentally. So if you recognize 37, the product of 37, 43, we simply do 40, the quantity 40 minus 3 times the quantity 40 plus 3, and what we know about the difference of squares is we simply square 40, then subtract the square of 3. Okay, so that becomes 40 squared minus 3 squared, or 1600 minus 9, or 1591. Okay? Okay, another concept in this lesson, which we'll be covering right now, will be the Pythagorean triple. So according to the Pythagorean theorem, the sum of the squares of the measures of the legs of a right triangle equals the square of the measures of the hypotenuse, basically saying a squared plus b squared equals c squared. And if I want to, we want to make this, okay, so basically what it's saying is that the sum, the squares of a squared, right there, if I make that a square, well, let me just draw it out. For the Pythagorean theorem, this is what it's saying, is, let me find my, there you go. So if this a squared plus b squared, that should look like a square, should be equal to c squared. Oops. Okay, so that should be like a square as well, but it looks like a rectangle. Oops, it looks like a triangle. Never mind. So basically what it's saying is that if I have A and if I have B and I square both of them, the sum of their squares will be equal to C squared. Okay, and that's the Pythagorean theorem. Let me delete this. There you go. Okay, so A squared plus B squared equals C squared. And then we move on to Pythagorean triple. So basing it on the Pythagorean theorem, a Pythagorean triple is a group of three whole numbers that satisfy the equation a squared plus b squared equals c squared. Okay. For example, the numbers 3, 4, and 5 form a Pythagorean triple. Why? Because if I have 3 squared plus 4 squared is equal to 5 squared, and we know for a fact that it is. So that 3, 4, and 5 form a Pythagorean triple. Okay. Now you can use the difference of squares to find the Pythagorean triple. Okay. So let's take a look at example number 4 and see how this is done. Before we do this, the secret word for this particular lesson is manger. The secret word would be manger. So find the Pythagorean triple that includes 8 as one of its numbers. So first things first, let's do this step by step. First, find the square of 8. And then we know that the square of 8 is 64. Factor 64 into 2 even factors or 2 odd factors. So either one, 2 even factors or 2 odd factors. Okay? So let's do 2 even factors. The 64 is equal to 2 times 32. Okay? And after that, find the mean of the 2 factors. Finding the mean simply means that we need to add 2 plus 32 divided by 2 will give us 17. That's our mean. And then we simply complete this statement using our mean. 2 times 32 is equal to quantity 17 minus blank times the quantity 7 plus blank. So what will you subtract from 17 to give you 2? And what will you add to 17 to give you 32? And the answer, of course, is 15 and 15. Okay, so 17 minus 2 is equal to 2, and 17 plus 15 is equal to 32. Okay, so you have two numbers now. Okay, 17 squared, using the difference of squares, that will become 17 squared minus 15 squared. Therefore, okay, 8 squared is equal to 17 squared minus 15 squared, or 8 squared plus 15 squared. If I add 15 squared to both sides, will be equal to 17 squared. So the numbers 8, 15, and 17 form a Pythagorean triple. Okay? I hope that makes sense. And I think, and I hope that's the last example. Yes, it is. Thank you for watching.